Have you ever wondered why reference assignment is atomic in Java? It's a question that many developers grapple with. Today, we're diving deep into this topic to uncover the truth behind atomic reference assignment. I totally get it. It can be confusing when you hear terms like atomic and reference assignment. You're not alone in this. Many developers have similar questions, especially when working with Java and the JVM. Let's break down the specific questions that have been raised. One user asked, is atomic reference assignment guaranteed in Java, or is it just a coincidence? They also wondered if this applies to other languages that compile to JVM bytecode, like Clojure or Groovy. Sound familiar? Let's explore these questions together. To understand this, we need to look at how Java handles reference assignments. In a 64-bit JVM, reference assignment is indeed atomic, meaning it happens in a single step without interruption. But how does this work without atomic pointers? Let's find out. And stick around. By the end of this video, you'll have a clear understanding of atomic reference assignment and how it affects your coding practices. To address the user's question about atomic reference assignment in Java, we first need to clarify what atomicity means in this context. Atomic reference assignment ensures that when a reference is assigned, it happens as a single, indivisible operation. In Java, the specification guarantees that reference assignments are atomic. This means that when a reference is assigned, it will either complete fully or not at all, without any intermediate states visible to other threads. Now, regarding other languages that compile to JVM bytecode, such as Scala, Clojure, and Groovy, they inherit this atomicity from the Java virtual machine. Therefore, reference assignments in these languages are also atomic. Finally, the user asked how reference assignment can be atomic without using atomic pointers internally. The JVM is designed to handle reference assignments in a way that ensures atomicity through its memory model, which abstracts away the need for atomic pointers. Fun fact, the term atomic in computing comes from the Greek word atomos, meaning indivisible. Just like an atom, atomic operations cannot be broken down further. Now let's look at the answers provided by other users. According to another user, the Java memory model specifies that reference reads and writes are atomic. This applies not only to Java, but also to other languages like Scala and Kotlin, as they all compile down to the same bytecode. Therefore, the atomicity of reference assignment is a requirement of the Java virtual machine, ensuring it applies across different languages running on the platform. Here's a takeaway. Understanding atomic reference assignment can help you write more efficient and thread-safe code. Keep this in mind as you develop your applications. And there you have it. You now know why reference assignment is atomic in Java and how it applies to other JVM languages. If you found this video helpful, don't forget to subscribe for more insights and tips on programming.